Okay, now that you know valence electrons, now we can talk about Lewis structures. Well, Lewis structures is just one of the things you can call it. You can call it Lewis dot structure, Lewis dot diagram, electron dot diagram, lots of versions of it. Basically, if it sounds something like that, it's probably referring to what we're about to talk about. Here are the objectives. Pause and peruse if you wish. Lewis dot structures are used to visually represent valence electrons. So they're simplified drawings of how valence electrons are arranged around atoms. Use the periodic table to find the electron configuration. Remember, the last number is the number of valence electrons. Carbon has 4 valence electrons. Electron dot diagrams are going to use that number, the number of valence electrons. So we're going to use the symbol of the element, use dots to represent the valence electrons. 1 dot equals 1 of valence electron. For the number of dots, the minimum number is 1. You can't draw 0 dots. And the maximum number is 8. Just like on the periodic table when we looked, and the largest number we saw for valence electrons was 8. So 1 to 8 dots. You cannot draw 35 in some weird combination. You can't draw 20. 8 is the maximum. 1 is the minimum. 1 dot per electron. Let's do an example. See the note at the bottom? Paired electrons will usually not bond, and unpaired electrons will usually bond. So when we talk about bonding later in a later unit, we'll come back to this. So let's draw the Lewis dot diagram for fluorine. First, you write the symbol, F. Find the valence electrons next. So you look at the periodic table, I see 7 as the last number. So now we're going to draw 7 dots around the symbol. But watch how I do it. 1. I always start at the top, but to be honest, it doesn't matter what side you start on as long as you follow the same pattern that I'm doing, which is 1 on the top, 1 on the right side, 1 on the bottom, 1 on the left side. That was 1, 2, 3, 4. 5. Now I pair it up. 6, 7. And that's it. I have 7 dots. So remember, paired electrons will usually not bond, so you see the pair on the top. So here, let me just show you. This pair right here, they won't bond. See this pair right here? They won't bond. See this pair right here? They won't bond. This right here, though, this is an unpaired electron, so will bond. So you can tell from the Lewis dot structure that fluorine will usually form 1 bond. Let's do another example. Let's do lithium. First, you write the symbol, Li. Then you find the valence electrons, 1. So we're going to draw 1 dot. That's it. Next, let's draw the Lewis dot diagram for aluminum. Write the symbol, Al. Find the valence electrons. So now I need to draw 3 dots. 1, 2, 3. Now, since aluminum has 2s filled, which we haven't even talked about yet, sometimes the Lewis dot structure for aluminum is drawn like this. Same with boron, but this way, right here, this one is usually the way you'll see it, but you can sometimes see it this way. So I just wanted to make sure I showed it to you so you would at least have seen it. Note, it doesn't matter where you start. Just put 1 dot on each side of the symbol before doubling up. Go in the same direction. I always go clockwise, but if you want to go counterclockwise, it doesn't really matter. But you just have to follow the same rules. Each side gets 1 dot before you double up. So lithium, which has 1, could look like this, or this, or this, or this. It doesn't matter. It's the same. So draw the electron dot diagram for sulfur. Write the symbol. Find the valence electrons. Draw 6 dots. So like this, ready? 1, 2, 3, 4. Each side gets one before I pair them up. 5, 6. So it has 2 pairs. Those won't usually bond, but 2 unpaired. Those are the ones that we usually bond. So sulfur can form 2 bonds. Let's draw the Lewis structure for nitrogen. Notice how I'm using the different terminology because you'll see all different terms. Nitrogen should look like that, 5 dots. Magnesium, Lewis dot structure, should look like that, it's 2. Carbon should look like that, it's 4. Neon should look like that, it's 8. 8's the maximum, and you notice all of them are paired, which means neon, a noble gas, does not form bonds usually. And that's it. That's Lewis structures, Lewis dot structures, electron dot diagrams, Lewis dot structures, all the ways we can call it. But hopefully today you learned something new.